Okay, so we have seen this yesterday as well, and we need to come to the detailing of that. So we have seen these various types of rainfalls that occur orographic and convectional, and this is how uh, air mass will rise. And we have spoken about the various ways in which air masses are made to rise. And today we are to speak about the tendency of air being stable and unstable. This stability and instability actually effectively will lead to formation of say clouds and precipitation and so on and so forth. But how does this actually happen is to be noted. Okay, and you'll see that as far as this rising air is concerned, rising parcel of air is concerned, and this air, say the air around is concerned, what is the relationship in between them? Whenever an unsaturated parcel of air is lifted, it expands and cools at a dry adiabatic rate of 10 degrees per 10 degrees centigrade per 1,000 meters. Conversely, when it sinks down, it will be compressed and it heats up at the same rate as such. Okay, so while it goes up, it is going to, while it goes up, okay, it's going to cool, and while it comes down, it's going to warm up. Okay, you'll see that because the pressure on it will be released, it will get to be of a larger size, and when it gets to be of a larger size, the volume increases. Because the volume increases, the temperature decreases. This is called as adiabatic heat cooling when it goes up, and it is going to be called as adiabatic heating when it is going to come down. Okay, there are different rates of adiabatic heating and cooling. Okay, we have seen them that the normal lapse rate is 6.5. Wet adiabatic lapse rate is around 4 to 6, and dry adiabatic lapse rate is going to be uh, um, say 9 onwards or 8 onwards. Okay, wet adiabatic lapse rate is though that is near saturation, and dry is which is not saturated as such. Okay, you'll see that this is what happens in the two types: the wet adiabatic lapse rate around 5 degrees, the dry adiabatic lapse rate around 10 degrees as such. What we have to take into consideration is this rate is applicable to this only. Okay, the surrounding air is called as environmental air. Okay, also called as, and the lapse rate there is called as environmental lapse rate. We want to use that to understand how air gets stability, how air gets unstable, how air gets absolutely stable, and how air gets absolutely unstable as such. Okay, this rising is actually an output of what is called as instability. There are four types of mechanisms that cause air to rise. We have orographic, we have seen earlier. This one is this is orographic. Okay. Then we have frontal wedging. This is frontal wedging. This is the warm. This is the cold. This is frontal wedging. Wedge म्हणजे हे असं it moves up and this way. This is the warm. This is the cold one. They move into each other. This is called as wedging. Okay. Then you have convective lifting. Okay, we're going to do that. And convergence is something that you see in tropical cyclones. Tropical cyclones. Okay. So where you're going to have low pressure, you'll have convergence. Okay, that is how you can remember it as well. Uh, I told you all that the surrounding air, the air which is going to surround this particle, these particles, this will cool at what is called as an environmental lapse rate. Here you'll see that the environmental lapse rate is 5 degrees. So the surface temperature is 25. It decreases by 5 and decreases by another 5 as such. But as far as unsaturated packet of air is concerned, when it rises, it decreases by 10 degrees, rises, decreases by 10 degrees. Okay. And effectively now what happens is while both of them started at the same temperature at 1 kilometer, this is cooler by 5 degrees. At 2 kilometers, this is cooler by 10 degrees. Okay. Now because this is cooler, this will become heavy. Because this is heavy, okay, there will be a tendency to come down. Okay, so whenever there is a tendency to come down, these are called as stable conditions. When there is a tendency to go up, these are called as unstable conditions. Okay, now there could be a stage wherein you have partial stability, partial instability. This is called as conditional stability, and it is these three states of air that we are going to study one by one. Okay, we'll start with the first one, absolute stability. Stable means, as I've already said, the tendency is to come down. Why should it come down? Okay, to understand what you see in front of you, let me explain this diagram in front of you. You have two parts of this slide. You have A and you have B. Part B is the graphical representation of the conditions showed in part A. Part A is the rising air parcel which stays cooler and heavier, and that is why it is producing stability. Now, what happens? Okay, you'll see that this side here you have the altitude. Okay, 1 kilometer, 2 kilometer, 3, 4, 5. Okay, then you have cold air here, and this part is warm air. Okay, so when they are meeting each other, warmer air is pushed up. Now this pushing up will be seen in a particular way. Let us understand it. Now, what is happening? You'll see that the surface temperature is 20. The environmental lapse rate is 5 degrees here, and the surface temperature is 20. Obviously, the air parcel is also going to be at 20. It is now made to rise. Okay, this is unsaturated. This is unsaturated, so it will move at 10 degrees. So by the end of 1 kilometer, 20 will come down to 10. But here, okay, 1 kilometer, there will be a drop of only 5 degrees because the environmental lapse rate is 5. Normally at low temperatures, the environmental lapse rate is low. If the temperatures are high, the environmental lapse rate is higher. We're going to see this in the next diagram. Now, you climb another kilometer from 1 to 2 kilometers, this temperature will fall to 0, while this has fallen to 10 only because 15 minus 5 is going to be 10. Okay, now let us say that here you have condensation. Okay, condensation, by the way, if it can be explained as saturation plus 1 or plus X, whatever you can say. Saturation is 100% relative humidity. Anything above this will lead to condensation. So saturation plus 1 is going to be condensation. Okay. When this is condensed, that means this is saturated. That it is saturated means that now the lapse rate is going to be wet adiabatic lapse rate. So instead of falling at 10 degrees, it will fall at 6 degrees. So from 0, it will go to minus 6. From minus 6, it will go to minus 12. From minus 12, it is going to go to minus 18. All this happened with the air going up here. The general air around is still falling at around 5 degrees only. So what happens is, let us start at 5 kilometers. What is the scenario? It is minus 5 and this air parcel is minus 18. Now because this is heavier, minus 18 is going to be heavier than minus 5, the tendency is going to come down. Okay. Now, if we see it here, minus 12, okay, it is minus 12. It is still high, lower than 0. So it's going to be coming down. This is minus 6. This is 5. This is heavier. This is going to come down. This is 0. This is 10. This is going to come down at every level. So because the temperatures of all packets of air at different levels is going to be lower than these temperatures. It's going to be lower. That means they are going to be heavier. Because they are going to be heavier, the tendency is going to be to come down as such. Because the tendency is going to be come down, you see that this is called as stable. And at nowhere it is warmer than the normal air. That's why this is called as absolute stability. Even though it will go up, okay, you'll see that it will still remain heavy and there will be a tendency to roll down back. And that's why this condition is called as absolute stability. This is how it operates. Now, the same thing expressed in a graphical way. Okay, environmental lapse rate is stable, and that is why you'll have a very clear line of the environmental lapse rate. This is that line. Okay, the rising air parcel, it divides into two. In the earlier part, the rate is faster. So you'll see it is steep till here. From here to here, it is steep. This part is steeper. And then this part is gentle. This is gentle. This is steeper. Okay. However, steeper or gentle, this curve, okay, of that air mass, this curve always stays to the left. Okay, this stays to the left as long as any curve of any air mass rising is to the left of the environmental lapse rate, you are going to have stability. This is the simple way of understanding what is stability. The curve has to stay to the left of the environmental lapse rate. Okay, that means it has to be colder than the environmental lapse rate. As long as it is colder, it will be heavier. As long as it is heavier, it will tend to come down. As long as it tends to come down, it will always be a stability condition, absolute stability conditions. This is how environmental lapse rate is, absolute stability is measured. Now, let us move to, and in case of stability, what happens is you have very stable conditions, and these are the best conditions for hot air balloons. And of course, whenever you see a hawk or an eagle just floating, okay, you'll see that that is going to be a stable, an absolute stable condition as such. Now, as against this, okay, what is going to be the absolute instability? Okay, you'll see that from absolute stability, we have added instability. Okay, now you'll see what has happened. Okay, this was the environmental lapse rate here. The environmental lapse rate is here now. The curve was to the left. Now the curve is, the curve is now to the right. Okay, what has actually happened? I told you all that for this to move to the right, okay, you have to have very hot conditions. To show the hot conditions, you already have the sun here. And while the temperatures were low here, as low as 20 degrees, you'll see that the temperatures are high. Okay, the temperatures are high. Because the temperature is high, the environmental lapse rate is also very high. It is as high as 12 degrees per kilometer. So if I'm going to start the surface temperature at 40 degrees, the temperature will fall to 28 in 1 kilometer, 16 in 2 kilometers, 4 in 3 kilometers, and minus 8 in 4 kilometers. This is the temperature of the general air. It's same, and that is why you'll see that this curve here, the environmental lapse rate curve, is very straight. But you'll see that the curve here is seen to be much steeper as compared to this. Okay, this is gentle. This is steeper. That means here the temperature is falling very slowly because it is 5 degrees. Here the temperature is falling very fast because it is 12 degrees as such. Now what starts happening? Okay, let us say an air mass gets heated and then it is made to rise. Because it rises adiabatically, the temperature falls at dry adiabatic lapse rate, that is 10 degrees, and it falls down to 30. What happens is the rising air is now 2 degrees warmer. Because it is warmer, it will be light. Because it is light, it will make an attempt to move up. As it moves up, it will further decrease in temperature from 30 to 20, but the surrounding temperature is 16. The rising air is higher by 4 degrees centigrade, and because of that, it will still tend to move higher. While it tends to move higher, saturation point is reached. Saturation will lead to condensation. Condensation will lead to formation of clouds. Because this is saturated now, it will not climb at a rate of dry rate. It will now climb at wet rate. Wet rate is 6 degrees. Okay, so it will fall from 620 to 14. That's a fall of 6 degrees only. Okay, and while the air around continues to fall at the same level, it has come down to 4. This is plus 4. This is plus 4. This is plus 14. So this is still warmer by 10 degrees. Okay, and it will have a tendency to move up lighter, and you'll see that the relative change is higher. Okay, here there was a difference of only 2. This has gone up to 4. Now it is more, very much more, 10. And another kilometer, it will be a difference of 16. The temperature will be 8 here, and this is going to be minus 8. So this is further going to increase as such, thus developing clouds, towering clouds. This is what happens during a convectional rainfall. Okay, and you'll see that as it tends to get steeper, these two lines, they tend to get go away and away from each other. Okay, the more distance that you will find between these two lines, okay, larger is the possibility that the effect is going to be more. Okay, the effect of the thundering, the intensity of the rain, etc., is going to be very high. Because the tendency continues to go up, this is called as absolute instability. It is unstable and it tends to rise very fast. The air parcel tends to rise very fast up here as such. This is the second condition. From absolute stability, we have moved to absolute instability. And then when you have a mixture of both of them, that is called as conditional instability. Conditional instability is very interesting. You'll see that here initially the curve is to the left, okay, and then slowly the curve crosses to the right. Okay, the environmental lapse rate is straight, but this curve, okay, it keeps on twitching here and there. So what happens? Here you have to have a conditional, environmental lapse rate of 9 degrees. Okay, so if you start at 40 degrees, it will come down to 31, 22, 13, 4, and minus 5. Let us say you have a warm air mass moving from here and you have a cold air mass moving up here. That leads to lifting. Because of this lifting, which is happening at 10 degrees, initially 10 degrees, it will come down from 40 to 30. And this has gone down to 31. So the temperature of the rising air is cooler by 1 degree. Another kilometer, it tends to be cooler by 2 degrees. Okay, cooler by 2 degrees. And the tendency till here, because it is cooler, this is 20 degrees, this is 22 degrees. This is heavier. Because it is heavier, the tendency is to come down. You can see here, the tendency is to come down as such. And then you'll see that at this level, saturation takes place. Saturation takes place, leads to Condensation. Condensation leads to formation of clouds. Now what happens? Because clouds start forming, this is saturated. Saturated means it will move to wet adiabatic lapse rate. The next kilometer, instead of falling by 10, it will fall by 6 only. So it will move from 20 to 14, while this has moved from 22 to 13. What has happened? While the rising air till 2 kilometers was cooler, now at 3 kilometers, suddenly the rising air becomes warmer by 1 degree. Okay, because it gets warmer, it further goes up, cools by wet adiabatic lapse rate. From 14, it goes down to 8. However, the normal environmental lapse rate is further down here. So while this is 8, this is 4. So this is warmer, this is cooler. This will go up. As it goes up by another kilometer, it will say cool down by another set of 6 degrees. And because of that, you will see that the rising air is as high as 7 degrees warmer as compared to 5 degree minus 5 degrees, the temperature at 5 kilometers as such. Okay. So because of that, suddenly here there is a tendency to go up. Here there is a tendency to go down. As I said, if you are to the right of the environmental lapse rate, tendency is to go up. If you are to the left of the environmental lapse rate, then the tendency is to go down as such. Okay, because it depends on the condition. This is called as conditional instability also. Okay, so these are the 3 levels, conditions, I would say. And these are the initial conditions, and so on and so forth. The 3 types of rains that we have seen. Okay, what happens in I'll keep it this way, sorry. Okay. Now let us see what is happening here. Let us understand, let us see if we can understand what actually is happening in an orographic rainfall. Okay, the dew point at condensation 20 degrees centigrade, dry adiabatic rate 10, wet adiabatic rate is 5. Now, the starting temperature is 30 degrees, you'll see here. Okay, when it climbs by 1 kilometer, it will fall by 10. So it comes to 20. Because it gets colder, it starts depositing. Okay, its saturation point decreases. Because it gets colder, the saturation points decreases. So the relative humidity is reached faster, or say cent% relative humidity is reached, because of which it will deposit rain. Because it deposits rain, it gets higher. Okay, but now what has happened is, because of condensation, okay, it will not fall at the rate of 10 degrees, it will fall at the rate of 5 degrees, 15 degrees now. Okay, and further another 5 degrees, so 10 degrees as such. Okay, by the time it comes to the top, okay, it loses a lot of its temperature, it loses a lot of its water vapor also. On the other hand, it now, the other side, it starts coming down, it starts heating. Because it is dry, it starts heating at a dry adiabatic lapse rate. Okay, so from 10, it descends down by 1 kilometer, the temperature rises to 20. Okay, so you'll see that now this side, the left side, the temperature at 2 kilometers is 15, but the right side, the temperature at 2 kilometers is 20. This is warmer. This is further pushed down, the temperature increases to 30, it increases to 40. So what started at 30 degrees actually goes around and ends at 40 degrees. And at this 40 degrees yesterday, we saw that the mixing ratio is very high. So it will absorb whatever moisture is there. And that is why you will not have rain here. And that is why this is called as the rain shadow region as well. Okay, this is orographic rainfall. Okay, this is the effect of an orographic rainfall. This is convectional. We have seen this, that the sun heats the ground and water and evaporates. The water vaporizes, okay, and then it cools down here. Okay, as it goes further up, okay, it is going to pour down a lot of rain. in selective areas as such, convectional rainfall. And then, of course, we have this frontal wedging, as it is called. Okay. Warm air is being pushed up. Because it pushes up, okay, it's very similar to this pushing, okay, or this pushing. It's only that here you have a physical obstruction. Okay, you actually have a mountain to obstruct it. Here, who is obstructing? There is no physical obstruction, but you have an obstruction of a cold air mass. Okay, this is dense, so this will not allow it to go this way. It will have to rise. As it rises initially, it will rise in the form of dry adiabatic lapse rate. If it cools faster, of course, it is going to give out a lot of rain if the temperatures fall, and at that temperature, the potential to hold on to water is going to be much less as such. So this is what we had to do as far as stability, etc. is concerned. Okay, I've finished, but then we'll discuss a few things before I actually sorry. I had noted down yesterday that you are supposed to be writing your assignments on circulation of atmosphere, right? By the way, please, there is some issue with my tracking attendance tracker. Please write down your names in the chat box. Okay, all 17 of you all, please write down your names in the chat box as well. While you write down their names, also pay attention here. Circulation of atmosphere, pressure, winds, the two types of winds, that is geostrophic winds and gradient winds, right? Yes, that was one assignment. The next assignment is going to be on jet streams. Please note it down. It's going to be on jet streams, one section. The second section is going to be of what we have done, evaporation and condensation. Evaporation and condensation of water you could add there. And then the third part of it is stability and instability. Or write notes on absolute stability, absolute instability, and conditional instability. These three notes. Draw diagrams wherever necessary. Of
लास्ट
course, I
वाला
don't
एकदा
have to
रिपीट
take
करा ना.
absolute stability, absolute instability, and conditional instability.
तर इनस्टॅबिलिटी आणि अजून काय लिहायचं
Absolute instability,
सर त्याच्या आधी
absolute stability, आणि शेवटचं conditional instability.
परत एकदा सांगा ना सर क्वेश्चन सगळे.
Jet streams. Okay, factors affecting evaporation and condensation. Okay, measuring एक राहिलं, various measures of humidity. Various measures of humidity. आणि absolute stability, absolute instability, and conditional instability. याची सबमिशन डेट तुमची राहील जानेवारी, आज किती आहे 25 जानेवारी, 25th Jan. All submissions to date to be submitted by 25th of Jan, including weather and radar.
Okay, sir.
The only two assignments that will remain is आता मी जे उद्यापासून सुरू करणार आहे air masses is something that will remain. and your assignment on a webinar will remain. I'm in contact with them. They said they have mailed the certificates, but you have not received them. I'll just check with them once again. And while you, if you have attended, obviously you know the content, so you've already may have started writing upon, say, after having selected one topic in that. And what you'll have to do is you'll have to upload your certificate along with your assignment, certificate of attendance of webinar along with the assignment is something that you have to upload as far as the last submission is concerned. That will be your last submission.
सर क्लासरूम मध्ये पूर्ण अपलोडच होऊन नाही राहिले आणि झाले तरी मग ते दिसत नाहीयेत.
असं कसं होईल?
सर मी काल ट्राय केला होता.
सगळं एकेकामध्ये नाही करायचं ना, एकेका असाइनमेंट मध्ये जायचं आणि करायचं.
हा सर एकच केलं होतं ते सबमिट, बट होत नव्हते आणि झालं तर मग ते दिसत नव्हते.
नाही नाही, व्हायला पाहिजे. आता मी BSc BA सगळ्यांचे असाइनमेंट्स आम्ही सबमिट करून घेतले. बाकी